So shadows of deep learning is just something very bombastic that I use to describe what I call shadows. And what I call shadows is something that goes along with your object, just like it would go along with an object. You know, it casts a shadow, you remove it, it disappears, you come back to it, it reappears. Then it's the same with objectives. You try to do something in machine learning and you end up doing a lot of shadow stuff that you didn't intend to. And I will explain what I mean. So first I will explain what I do not mean, okay? So you all know the Netflix prize. It was a great challenge in basically in matrix factorization, and the winning team managed to improve the best results by 10%. So this is very much what really shaped recommender systems for researchers, and now people are introduced to this problem. You have a set of users, a set of items, a set of ratings. You don't know everything, predict the missing stuff. Okay, we all know it. So the winning solution for this was a really complex ensemble method with like 107 components, and it was a combination of several teams. Each team did not very well, but combined and suddenly broke the ceiling. So maybe there on Zing you should just take the top 3 teams and combine it. Who knows? Maybe it will be better. And also the second best solution was actually the one used in production because it was simple enough to implement. The better one was just not worth it. Even Javier Amatarian, who is one of the data scientists at Netflix, wrote about it in their blog. It's just not worth the runtime and everything, that just isn't worth implementation. So the shadows of the Netflix prize over the entire work on recommender system is that if this is the problem definition, then we have to ask ourselves, is this the problem definition as we all know it? So since you're all recommender experts, I did not expect that this would be the audience. So we know that the answer is no. Sometimes you don't know your users. New users are arriving and old users are getting removed or stop or churning out from usage. The items are always changing. Maybe we shouldn't predict scores. I mean, if we measure by RMSE, we want to know if it's close to the rating that the user would give. So who cares? Maybe ranking is enough, and I just want to know what is the first film to show, the second film to show, etc. So there are many other approaches that you can use and should use for this problem. But I'm asking you something different. I'm asking you whether training a recommender is our only job when creating a recommender system or a website that uses a recommender system. So I'll start with a story about an actual company. It's called Avito. It's a website for classified ads in Russia. You can say that it's the Russian Craigslist because it's that big. 35 million unique users each month. And in the slides you will find links to interviews and the transcript of the interviews with one of their data scientists. And it's free to post there. It isn't free to repost. You have to pay for it. So this is what Avito does. Naturally, if you have classified ads, just like in Zing, then you need some ranking, you need some search engine, you need to do some personalization, which you achieve by recommendation system. What classified ads should I show to each user? And they also add some several Kaggle competitions, so you can even have a look at what their data looks like. But also they have shadows. And by shadows I mean ads with prohibited content, people trying to sell drugs and guns and whatnot, that we have to remove. They don't want this to appear on the website. So I think that it would be equivalent if somebody on Zing would offer you to be a drug dealer or something like that. I don't think it happens a lot, but in their case it does. Also, what brought me the inspiration to this talk is that in Russia there's an entire shadow industry of companies that would repost your ad in Avito for a smaller price. So it's amazing. Think about it. There are some people coming to work every day and say, okay, so today I'll work on cheating Avito, and if Avito closes, then these people will find themselves jobless. And this is their entire occupation is just being a parasite on top of Avito. So I think that it's just crazy. And the conclusion of this is you wanted to create recommender systems and have fun with recommendations, but you end up doing the duplication of ads and finding fraudulent people and doing text analytics, this time in Russian, so many of the works on NLP are relevant. And the same goes for many verticals. You wanted to do one thing in data science, like recommenders, you end up doing entirely different stuff, and even Lady Gaga proves it, so you know it's true. So there are many other examples of what I call shadows. Some of these you know. So freshness and lack of freshness. I used it to work in a company that created email recommendations. Once we got several emails back to us saying that the emails were the same for several times. So we found that it was a bug, we fixed it, and now every email contained brand new recommendations, and the sales just dropped in half. Because apparently people, maybe they don't like seeing the same stuff exactly, but maybe they like it in a different order, or they like just one new product every time. But if you show them the same product enough time, you will hypnotize them and they will end up buying it. So freshness is very interesting. It's very nice to have. I don't know, maybe in a news website it's important, but in e-commerce it isn't. If you go to Alibaba, for instance, you will see that you're still getting the same old recommendations because they suppose that you're stupid, and maybe they're in some cases correct. Getting rid of excess stock is the general term I give for business requirements. Sometimes your recommender tells that you should recommend, I don't know, this amazing camera, but then the shop owner for which you work and implement the recommender system for him comes and tell you, I have to sell these shoes, I have tons of shoes that I have to get rid of, and you end up skewing your recommendations according to the business needs. So sometimes it doesn't matter how smart your algorithm is, it just gets ignored. Weather and other features. Weather is just another broad term I use for any sort of features you have to get, and you don't get it from the data, you have to go to outside resources. And for the prices of a fancy sandwich is a reference to some competition that Yelp, not a competition, but some sort of demo that Yelp did, and they have the code and a blog post about it on their website. They use the common crawl data, which is the entire internet, all the text of all the web pages released monthly, and they try to match pages that they had on Yelp. Yelp is the American Yellow Pages, it's just a list of businesses and the reviews. They try to match between businesses for which they had the phone number but not the website, or businesses for which they have the website but not the phone number. So they crawled the entire internet, did these matches, and actually added more data, which they could later use for their recommender engine. So it's a very nice work, you should look it up. And by Google AdWords and Facebook API, I mean everything that we get usually from Google or from Facebook, which really changed the way recommenders work, because suddenly we know the referrals many times, and we know all sorts of stuff that either Google or Facebook collect about how people reached us and what categories are the pages from which they reached. And some people try to crawl for this data for free instead of buying it. So this induces all sorts of API wars. They change the APIs a lot, and then you have to change your code a lot, and it's very annoying. I know a certain company in Israel that used to use the MAC addresses of phone numbers. I'll explain. This company was a security company, because naturally it's Israel, and it tracked people according to the MAC address that their phones send out when they look for Wi-Fi, okay? Even if you're not connected, you send out your MAC address looking for a connection. It's somewhere in the frame, and they could track this. They can track you by this. So this is technology used in other places. For instance, in the US, there are supermarkets who track you, and when they see that you come again, and they somehow assign this MAC address to you, then they will use it for recommendations. So in this time, Facebook are not the bad guys. Google and Apple found out that if MACs are being used for retail, then why don't we get some money out of it? So both in the new Android and the new iOS versions, Macs get randomized. You still have a hardware Mac on your device, but it's not getting used for scanning out for Wi-Fi. They send up some randomized Mac. The Mac address space is vast enough, so my randomized Mac will not collapse with yours and yours and yours. And if you want to know the real device that's behind this Mac, you have to pay for Google or for Facebook. So this was something coming from retail, used for recommendations, and this actually affected many other industries who had no plan B for that. They thought that, the Mac is inside the chip. What can change? It's hardware, but it wasn't hardware anymore, so it's very sad. I had really fancy animation. Wow, it's an amazing animation. I use this because I don't like the animations of PowerPoint, and then it still sticks me the animation of the transformations. So this is another shadow, and you can read about it, but I will be more explicit. Sometimes there is content that you should not show some users. So this, you can read it for yourself, but I'll tell you about a company that did text analytics, and one of their customers bought a car plug, and then he got a recommendation due to text services to some different kind of plug, which, I mean, you normally don't use it on your car, and he wasn't happy with this recommendation, so maybe they should have thought about it. I bet they did it now, but it also happens on Amazon, so it can happen to everyone, so beware of plugs. And now it's time for some demos. I think that this is going a bit faster than I expected, but never mind. We all want to go home, especially if we have a plane to catch on the way. So I'll show you some demos created with GraphLab Create. GraphLab is a Python library for machine learning. It's very fast, it's very strong, it's very amazing, and I won't tire with this. But we have all sorts of machine learning toolkits, and we can combine these machine learning toolkits to create, for instance, recommenders. So just like the previous talk said, you can use deep learning to extract image features from dresses. So for instance here, I looked for a dress, and somehow I got all sorts of images of dresses. And then, for instance, I can decide that I want, I don't know, a floral dress. And using deep features, I can find that this floral dress is very similar to this floral dress. People once asked me if it may be because of how the model looks, so hopefully not, because most of the model is a dress. But it's just another set of features that you can use. So this is exactly what you've shown us. You can also employ text analytics in your recommendations. So if you analyze the text, you can use the sentiment analysis, and then given products, you can compare two different products, and you can try to understand, besides of their price and average rating, etc., you can try to understand which aspects are mentioned in the text, and then how each aspect is scored by the sentiment analysis. So we can see that for this product, for instance, the range, the price, and several other factors are better. The battery life, for instance, seems to be better on this BabySense product. And then we can also look at the details of this recommendation and see how each sentences was tagged. Was it tagged positive or negative, and what was the aspect? So this is all NLP that is being used to improve the recommendations. By the way, there is a very known work by Dan Ariely, who is a economical psychologist, that shows that if you show people several offers and one will be significantly better, then I mean, you have to show some bad offers to make some of the offers look better. So maybe instead of recommending just one item, recommend a set of items and intentionally put inside some bad items to make the other items sell. Another demo that I really like is the pathways demo. I showed it today, so the people who are in the training earlier will have to see a different version. So let's say that I like a movie and I trained a recommender according to the Amazon dataset. So I can say that I like the movie Clerks. It's by Kevin Smith. It's a wonderful film, and you all should watch it. And if I like it, it's a comedy, then I get either other Kevin Smith movies, or I get some other stupid comedies. But then my wife wants to watch a film with me, and naturally she doesn't like this film because it's very stupid. So let's say that she'd like to watch Bridget Jones' Diary. The first one is not... actually, she's already won. So... Hey, thank you. So actually the first one is not very bad. The second one is just horrible. But of course I don't want to watch it. So we can, if we created a recommender, then we create some sort of similarity metric between each two items. If we can do that, we can now create a graph, okay? A network with the nodes being the items and the edges between the nodes being weighted by the similarity between the items. And because in GraphLab we have both recommender models and graph analytics models, then we can combine them and find the shortest path between what I want to see and what she wants to see. And maybe something in the middle would be appropriate. Okay, so this is a nice example. And of course, I'm a father to a 10 months old baby. So what really happens is that we go to sleep and we don't watch anything. But it's just nice that we have the theoretical option. A lot of people say, oh, your wife tells you what to see. So yeah, on the way she tells me what to see, but we don't end up really seeing it, we just sleep. So I want to give you some examples of companies that monetize stuff on the shadows. And by that I mean, first of all, I showed you some negative examples of how shadows might be annoying, but there are many things that maybe you didn't think about in recommendations and e-commerce that may be actually useful and nice. So the first company I'll talk about is called Yotpo. It's from Tel Aviv. And they try to collect and make the users send them some engagement data. So for instance, if I buy something from Amazon, then say, okay, it will take him approximately 3 days for the package to reach you. And then in 3 days after I buy it, they send me an email. So how is the product? Would you like to write a review? And you're all excited because you just unboxed it and you're wearing that wonderful dress and you look in the mirror and hope nobody will see you. So they end up harvesting photos generated by the user, reviews, movies, even user-generated contents. Now, if you are in a shop and you would sell one dress with 4 stars reviews, but with 400 reviews creating this average rating, and another dress with only 4 reviews but with a 5-star rating, then which dress would you choose to buy? The blue one? You sure you don't want the red one? It would look great on you. So the blue one is the one that you would choose because it seems more solid, okay? So actually getting, even after you, I mean, we always think how to recommend. After we recommend, the person buys, he buys, well, goodbye, we took your money, we suckered you out. But it's not the idea. If you can get money, if you can get a review out of the person, then you can actually improve your e-commerce website and maybe even improve your recommendations. So this is very interesting. Again, if I have text, and can use it for NLP, so it's very useful. Another entirely different aspect is cross-device tracking, like Crosswise do and Tapa do and many other companies do. I have here my laptop and I also have my iPhone, and at home I have my tablet, and maybe when I start buying something then I will look it up in my tablet, then on my way back home and along at work I will look at I will search it again on my iPhone, and I'll end up using my credit card with this laptop. And the advertiser would like to know that each one of these devices belong to me, so they have to do a lot of classification and graph analytics, and it ends up helping you getting targets. So you want to know that several different sessions come from the same user, and this is done using this cross-device tracking. It's an entire set of algorithms that you need to think about. The last one I'm going to talk to you about is OLX. I told you before about Avito. So Avito was actually purchased by OLX. OLX is a company that goes around the world. It's the biggest company you don't know in classified ads because they have like 300 million users. And they go to all sorts of developing countries. So one developing country is, of course, the United States, a very small country that you probably never visited. But they also have clients in India and Indonesia and Pakistan and the Arab Emirates and many, many more other countries. And in their case, everything I showed you about NLP, some of the NLP that we know is just useless. I mean, you can't do stemming because there are no proper stemmers. Sometimes there's what they call Barbie, really bad English, because people write things in India, so they use English characters, but what you would read if you get it is some sort of bad Hindi transcript. So you have to use only the traditional methods, and in that sense, deep learning may be interesting because you don't have to do any sort of pre-processing. You just feed it in, and maybe this will solve it for them. But many of the stuff that we think about when we're doing NLP has to be re-evaluated in their case. And of course, many of the stuff cannot be transfer learned, so they can't use methods from one language on a different language. They are now working on it. So, but doing this, they reach very vast markets. So maybe it is worth to go through this entire hustle of working with many different languages. Another one last example, they're not monetizing, but because it's academic results, it's called the aha moment. So they created a recommender system that would recommend worthy stuff for you. So for instance, if you want to buy some, I don't know, cage for your baby, then you can just as well buy a dog cage and it will be just as effective but cheaper. If you want, it does exactly the same thing. Believe me, the kids don't care, they are very small. They don't remember anything of this. And you can also put the dog with them and then they're even happier. If you want to buy, for instance, some sort of carpet for your butt so you don't want sleep, you can just buy something for your car or the stuff that you put on stairs, and it will be just as effective, but it will cost you much less. So this is a paper that's very interesting to read. I won't take any more examples out of it. So in summary, and I think that we can all be happy that we finished earlier. So recommenders is items that we show to our users, but sometimes it's a lot more than this. It's items that we have to hide from the users, and users that we have to hide from users, like malicious people and their malicious ads. And sometimes it's users that we want to show to our users, you know, elite users or users that make great recommendations or write interesting stuff on LinkedIn, etc., etc. So many different problems require a very flexible solution. And for this GraphLab Create was created, and we also have a machine learning foundation course that you can find on Coursera. It's free to take unless you want to pay for a certificate that you did it, but you don't have to. And if you take this course, you also get 1 year of free academic license to use our product. And that's it. So, any questions?
You showed this convolutional network example with the
Mhm.
Is that pre-trained?
We used we pre-trained it on we pre-trained an ImageNet. I think that it's the AlexaNet alone. Yes, and we give it away so you can use it with our toolkit. And apart from that, we just started to integrate MXNet. Because we're a Python library, then you can use other Python library with us, and with the best ones we also integrate. So we integrated with Spacey to get some more, to get their text analytics features working better on our platform. And now we integrated with MXNet, so you'll be able to do a lot of deep learning that's multi-core and out-of-core, meaning it will run on all of your cores and it will not be limited by the size of your RAM, but by the size of your disk. So the deep learning in our platform is just going to get better and better, hopefully. Anything else? Okay, you're free to go home. Goodbye.